Namaskaram. Good morning, all. In this video, we shall talk about IKS and the contribution of Indian knowledge systems to STEM. STEM would mean science, technology, engineering, and mathematics. In today's video, we shall talk about the historical development of mathematics and astronomy in India, which is a fascinating and rich journey that spans a few thousand years. These disciplines evolved in complex cultural, philosophical, and scientific context, contributing significantly to global knowledge. When we talk of mathematics and astronomy in India, it has a wonderfully rich contribution to the entire world. These are the great Indian mathematicians that existed right from the beginning till date. During the early Vedic period, which extended from 1500 to 500 before Common Era, mathematics was an excellent field of knowledge which is contributed by the ancient India. The earliest traces of mathematical thought in India came, of course, from the Vedic texts. The Sulbha Sutras, which are part of the Vedas, contain geometrical principles used for constructing altars and religious purposes. The principles include the use of Pythagoras theorem and concepts of approximations for the square root of 2. This is the Sulbha Sutra text, which are essentially used for the Vedic altars and the religious purposes of doing yagyas. In the world of astronomy as well, in this era, it was deeply tied to the religious rituals. The stars, or the nakshatras, which are the lunar constellations, were identified, and the movements of the sun and the moon were closely observed for creating accurate lunar and solar calendars. The Surya Siddhanta is a wonderful text in this aspect, contributing a lot to astronomy not only then but also today. When we talk about the classical period mathematics, extending from 500 BCE to 1200 Common Era, we have three important personalities: Aryabhatta, Brahmagupta, and Bhaskaracharya. Aryabhatta, who belonged to 476 Common Era, has titled a book called Aryabhattiya, which covered arithmetics, algebra, plane trigonometry, and spherical geometry. He introduced the concept of zero and the decimal place value system. He has not only contributed zero and decimal place value system to the Indian mathematics, but also to the entire world of global mathematics, as is very rightly emphasized and praised even by Einstein. Aryabhatta also worked on the approximation of pi, estimating it to be 3.1416, which is very close to the true value today. Brahmagupta, 598 to 668 Common Era, in his work called Brahma Sputi Siddhanta, he developed rules for operations of negative numbers and zero. Brahmagupta is credited with solutions to linear and quadratic equations and the introduction of methods for solving indeterminate equations. Bhaskaracharya too, who is between 1114 to 1185 Common Era, has a major contribution in the form of Siddhanta Shiromani, which had a profound impact on Indian mathematics, addressing concepts in calculus, algebra, anticipating the ideas of differential calculus as well. When we talk about Indian astronomy, it is called as Jyotisha Shastra. The development of Jyotisha or Indian astronomy was linked very close to mathematics. This period saw the compilation of several key astronomers and astronomical texts and models of planetary motion. When we talk of astronomy, again Aryabhatta is the number one profound influencer. Aryabhatta proposed that the earth was a rotating sphere and explained the cause of solar and the lunar eclipses. His mathematical work supported the calculation of the length of an year and also the positions of planets. Varahamihira 505 to 587 Common Era is a renowned astronomer who wrote the Panchasiddhantika, summarizing 5 earlier astronomical works that existed before him. He emphasized the use of mathematics in predicting celestial phenomena like eclipses and planetary conjunctions. Surya Siddhanta and Brihat Samhita are beautiful texts that are penned by Varahamihira. Bhaskaracharya too built on previous astronomical knowledge to refine methods for calculating planetary positions. He worked on complex astronomical calculations in his treatises, especially one of the treatises is termed as Leelavati, which he devoted to his daughter, whose name is Leelavati. In the medieval Islamic influence, which is between 1200 to 1600 Common Era, we find the interaction of the Islamic scholars and the influence of Persian and Arabic mathematics that led to a fusion of Indian, Islamic and Greek ideas. This period saw the preservation and further development of earlier mathematical and astronomical works, as you could find in Al-Biruni, an Iranian mathematician, astronomer and polymath. The introduction of Arabic numerals, which of course evolved from the Indian numerals into the Islamic world and subsequently into Europe, revolutionized the global mathematics. Indian trigonometry had a significant impact on the development of mathematical astronomy in the Islamic world. The concepts such as sine and cosine were further refined. When we talk about the modern contributions, especially during the colonial period onwards, the one figure that comes to my mind that has contributed a lot in mathematics is Srinivasa Ramanujan, the man who knew infinity. During the British colonial period, the contributions of Indian mathematics and astronomy were rediscovered and gained recognition globally through him. Srinivasa Ramanujan, 887 to 1920, made an extraordinary contribution to number theory, continued fractions, and infinite series. The establishment of scientific constitutions during the British Raj and post-independence India led to the further advancement of both pure and applied mathematics. The picture shows Madam Shakuntala Devi, the person behind the human calculator. Shakuntala Devi, 1929 to 2013, was an Indian mental calculator, astrologer, and writer popularly known as human computer. Her talent earned her a place in the 1982 edition of the Guinness Book of World Records. It is believed and said that Shakuntala Devi calculated faster than a computer as well. When we look at the impact on global knowledge, with respect to the Indian contribution to mathematics, Indian mathematicians introduced the world to zero, the decimal system, and significant advances in algebra and trigonometry. Their work on infinite series, combinatoric tricks, and indeterminate equations laid the foundation for further development of global scientific community. Indian astronomical treatises, particularly through translations into Arabic and Latin, played a critical role in medieval European astronomy and influenced thinkers like even Copernicus. So India has given number 1, the decimal system, number 2, 0, number 3, geometry, number 4, the pi, and number 5, trigonometry, calculus, and algebra. And so, in conclusion, we can say Indian mathematics and astronomy from the Vedic period through the medieval era and into the modern times have significantly contributed to global scientific progress. The innovations in geometry, algebra, trigonometry, and astronomical calculations provided a foundation that influenced scholars worldwide. The Vedic mathematics is now evolving as a wonderful piece of study to sharpen the minds of children in the modern times today. Thank you very much for being a part of this video. See you in the next video. Bye for today. Namaskaram.